Hello, welcome to this lesson where we are looking at volume of a conical frustum. Okay, and it's important that we get to know that this platform is meant for people that are writing their grade 12 exam as well as 9. This one is a grade 11 topic, so it is specifically meant for those people that are preparing for the grade 12 exam. Okay, so we want to look at the volume of a conical frustum. A frustum that comes from a cone. A cone. So we are saying when a cone, we have a cone here. We have a cone here. And we are saying a frustum is, a frustum of a cone is that part of the cone that remains if the top part has been cut off. If we get rid of this part, we remove this part, what we are remaining with this shape is what we are calling what? This shape is what we are calling a frustum. This shape is what we are calling frustum. Now this is that of a cone. So we're going also to look at a pyramidal frustum. Now here I'm concentrating on a conical one, the one that comes from a cone. So what are we supposed to do in order to find the volume of a cone? A conical frustum. So I'm going to present to you two methods, and then you are going to see which one is easier for you. Then that is the one that you're going to use. All right. So somebody derived this formula. And it is working, and it does help. So we have 1/3. We have 1/3 pi multiplied by h, then we have r plus. Okay, so I want you to look at this formula, and I'm going to explain what is involved here. So for instance, the cone that the frustum that I drew here. Okay, now you can see that from a cone we are going to have two circles here. There is a circle at the bottom. We have got this part at the bottom here. This is a circle. If we take this as a frustum, we have a circle here, and we also have a circle here. Okay, because this is the shape of this if it is in this manner. So we're going to be looking at things like this one. Okay, so we now need to find the radius of the bigger circle. The radius of the bigger circle here, and the radius of the smaller circle. There are also times when this same thing can be presented in this manner. Okay, we are still talking about the same thing. Okay, we are still talking about the same thing, just like I gave an example of this cup here. So this, we are going to have our radius, bigger radius there, and the smaller one here. So you can see that in our formula we've got the capital, or the bigger radius, which should come from the bigger circle, and the smaller radius, this r here, it's radius of a smaller circle here, because on a conical frustum we have on the two ends we have, on each end we have a circle. So we need to find the radius of that circle and also the radius of the other one. So this is what we are going to have. And on all these, we are going to always be given height. It could be given outside here to say maybe the height from this point to that point, it's 10 centimeters, or maybe it will be given from this point, say this height is 10 centimeters, still the same thing. So when you look at our formula, we have what? Height, the radius of a smaller circle, and the radius of a bigger circle. Those are the three characters. Okay, if you like, those are the three characters that we need to find the volume of this. We need the height, which is given here. We need the radius of the bigger circle, like I've explained that we've got a circle of a cone at the bottom, which is the bigger one, then at the top, which is a smaller one. Now we're talking about the radius or the radii of these two circles. So we are going to try and apply this formula to see what we are going to get. So this part comes in paper 2 and the calculators are permissible there. We can use a calculator and then you get your answer. These questions do carry 6 marks in the exam. So in our example, we have 1 over 3 multiplied by 1.142 multiplied by 6, which is our height here. Okay? Then in the brackets, the radius of the bigger circle is what? 4. So you need to square this 4. You need to square this 4 plus the radius of the smaller circle here, which is what? 2. Squared also, plus this is 4 now multiplied by 2 without being squared. 4 multiplied by 2 without being squared. Okay? So now we can go on this into 6. 3 into 6, what do we get? It's 2. So we have 3.142 multiplied by 2 here. Where did this 2 come from? I divided it by 3. Then this is going to be 16 plus 4 plus, what do we get here? We get 8. Okay? You can go down and say 3.142 multiplied by 2 multiplied by, what do we get here? This gives us 20, then we have 28. So you can multiply here and get your answer. We can multiply here and get our answer. Let's try to multiply. Let us try to multiply here. Okay, so we are going to get 3.142 multiplied by 2 multiplied by 28. Okay, so for me here what I'm getting is what are you getting? Work out something so that before you see mine, maybe there are differences. You should be able to see where. Here I'm getting 175.952. Now when you want to round off, when you want to write this to 3 significant figures, it will be 176 what? Centimeters cubed. Volume is always given, you have to give in cubes, so you have to write this unit correctly here. Okay, so this is what I'm getting when we use this formula. This is what I'm getting when we use this formula. I hope you have followed. Now maybe I should also mention that in some questions, what you're going to be given here, they will give you the diameter from this point up to that. Okay? And then you should know that what you need in your formula is not the diameter. Did you get what I'm saying? When you've got a question like you have something drawn like this, and then they have told you this is what? Maybe 12 centimeters. Then here, this is 8 centimeters. Okay? You should know that what you need, this is diameter here, this is also diameter, but what we need in our formula, we need radius and radius. So to get radius, you need to divide this by 2. Height will always be given here, whether this side or in the middle. Okay? Basically, this is what we are supposed to know here or about this formula. Some people worked it out and it proved to work for the volume of a frustum for the cone. Okay? So, let's see how we can try. Let's try to use another formula and see if we're going to get the answer. Remember here, the answer that we got is this one. Okay? The answer that we got is this one. So now, the formula that is very common in the books is where we write this one, we extend this one, okay? We extend this one as a full what? As a full cone. Then even this middle part, we extend it up to here. Okay? I'm trying to work out this using the other formula. So you know that the formula to find the volume of a cone, it's 1/3 h, isn't it? So what we want to do here, we want to find the volume of a bigger cone and the volume of a smaller cone which was removed. Then later on we subtract. So we are going to call the radius, like what we are doing there. The radius of a bigger cone, it will be r, capital R. Then the height of the bigger cone, I also write it in capital, then minus 1/3. This one is the volume of the smaller cone, and this one is the volume of the bigger cone. Okay? This one is the volume of the bigger cone. So if you want, again, these same two formulas here, we have something that is common, isn't it? We have something that is common, and we can factorize what is common, which is 1/3 r, then, pi. We have r squared h minus r h. These are two different because these are coming from the bigger cone and these are coming from the smaller cone. Okay? I hope we are getting the idea there. Okay? So, now, you know that for the bigger cone here, for the bigger cone, we do not know. We have, if you remember when we were looking at the volume of a cone, I told you that what we need to find the volume of a cone, it's the perpendicular height here. We need this perpendicular height. So we are looking at the perpendicular height of the bigger cone. We know that from this point up to somewhere here, we know that it's what? It's 6. So we know that this is 6 here. Are we together? Then, this distance now from this point up to the top part here, which we do not know, we are going to call it what? We'll give it the measurement of x. Okay? We'll give it the measurement of x. Then, we go on now to find this is what we have. Then for the radius, we have 4 centimeters. Are we together? Then, I also want to come up with so for the smaller, the cone, this is the bigger cone, like the whole cone now. Then I want to extract the smaller cone. We are saying the distance from here up to this part, this is what we said, it's x. Remember, we said for the bigger one, the perpendicular height is 6 plus x. Then this upper part here, it is x, and then the radius is what? It's 2. Then the radius is what? It's 2. I hope you are following. Then there, we need now to find the value of x. We need to find the value of x. Okay? It's important, especially if you looked at similarity and congruence, we established these concepts here. we established these concepts. So what I'm going to do now, it will be, I'm going to look at the corresponding sides. Okay? I'm going to look at the corresponding sides. So if I'm getting 2 from the smaller, 2 is a radius here. So this 2 corresponds to 4 on the bigger what? Cone. Then now we come to the perpendicular height. Please can you pay attention to the perpendicular height of the smaller cone? It's what? It's x over the perpendicular height of the bigger cone. It's 6 here. Remember, it's from this point up to this, it's 6, then plus x, which we don't know. So it's going to be 6 plus x. Alright? Then we solve this one now as an equation. How do we solve? We need to cross multiply. So we're going to have this 2, you multiply it, 2, 6 plus x is equals to, when you multiply this, you get 4 what? 4x. So we're going to have 12 plus, what do we get here? 2x is equals to 4x. So we have 12 is equals to, this one goes to the other side, we have what? 2x. Then x is equals to what? 6. So again, coincidentally, we are told from this point here up to the last part, we have 6. So meaning the height of this one, the height of the bigger cone, it is now, this is also 6, and then here we have got what? 6. So the height of the bigger cone now, it is 12. From this point up to that point, it's 12. Okay? It's 12. So now, after we have done this, we need, since we have known now, we were doing all this so that we get to know what the height of the bigger cone, which was not complete, and the height of the smaller cone, which was not there. So that is what we're trying to do. We needed to know what these two are. And that is what we have just established, that the height of the bigger cone is going to be 12. It is going to be what? 12. Because this part and this one, from this part up to this one, it's 6. Then again from here up to the top part, it is 6, the value of x which we got. So now, coming back to our formula, it is 4. Then our h, it is what? 6 plus 6, which is 12. Then the radius for the smaller circle is what? The radius for the smaller circle is what? 2. And the height here, from this point up to the height here, is 6. So it's the question of us now trying to substitute and put this in our formula. The formula is here. Let's see if we are going to get these answers here. That if we do not get these ones, or then we have to relook at our work. So we are going to say 1 over 3 multiplied by 3.12, open brackets. What do we have here? This is 4 multiplied by 12 minus 2 squared multiplied by 6. Okay? So let's try to work what is in the brackets first. We work what is in the brackets. Or you can do this at once. You can do it in bits, or we can punch this in at once, where we say 1 over 3 multiplied by 3.142 multiplied by, open brackets, 4 squared multiplied by 12 minus 2 squared multiplied by 6, close brackets. This is what I'm getting. Exactly the same thing that we got. This is what I'm getting. Okay? I punched it once and I'm getting the same work, which is this one. As it is here, this is what I'm getting even here. 175.952. If you have seen 16 there on the calculator, it is this 4. I just said 4 times 4, got 16. The other side there is 4 that side, I just squared this one. So we're getting the same thing. So as you've seen here, I've tried to use both methods. Methods and I'm getting the same answer. So it is also up to you to choose now between these two methods which one is simpler for you, and that is the one that you should be using going forward. But there is no harm, you can be trying both just to confirm your answers or just to be conversant with both formulas. Otherwise, this is what we are expected to find. It's as simple as that. It is as simple as that. So this aspect of corresponding sides, it's also important for you in an event where you're not given any of these, because for you to work with the volume, you need both radii. You need this radius and the other one here. Okay? So if you don't have the other, then you need to use this same part of corresponding sides to make sure that you get the other part. That is very important, like in the other example that you're going to see. Okay? So I'm going to give you all the questions that I have managed to gather from the past exam papers and other sources. They are not all meant for you to submit, especially those of you that do submit the work. You can submit 1 or 2, not everything, because there are a lot. It's difficult to mark. So you can, but I'll give you as many as possible for your work and stuff. So let me begin with what is in the past papers. The first one is this one. Sorry. This question. Solve it. Okay. Then we also have this question here. You see what I was talking about? Here you've been given diameters. So you need to make sure you find half of those to apply in the formula. Okay. Then we also have this question here. This side. Read this question. Okay. This question. It's the same thing here. Okay. Then the last one is this one. Read it. B part. The figure below is that of a cone. Okay. It's the same thing. Okay. I'm giving you all these questions so that you don't have challenges. Okay. I'm also give you some questions from the books. So, yeah. Question 23. Question 32, I mean. Question 32 and question 33. Question 33, the depth of 40 centimeters, that is height. Okay? Question 33, please take note of these questions here. Is this one 32 and 33? Okay? It's from this book. It has a lot of questions that you may need. There are more questions to come. There's this one, which is an example here. Read this question. It talks about find the capacity. You know, capacity is the same as volume. find the capacity. It was explained here. It's an example. I'll even do it. Then later on, you can check the work that they did here. And then the answer is here. This is the answer. Okay. Last, we'll have this question. I have this question here, copy it. This question. Just do the volume part. Just do the volume part. That's all. Okay. These are the questions that are directly related to what we looked at. These are the questions that are directly related to what we looked at. I hope we can answer all the questions under this part. Thank you so much.